Ladies and gentlemen, good evening. Tonight we're going to part 2 of the TypeScript code style guide. It's a long one. We started in the last video where we actually came to, and it's found at google.github.io style guide ts guide html. And it's the last time we actually ended up with the variable where we can actually see in the red boxes what we should never do, and we can see in the white boxes what we should do according to Google's TypeScript guide. I think it's quite good. If you are writing TypeScript code, then you should definitely read these ones. And then it is long, so just scroll through it and then look at all of the red boxes. That's at least what I did. So then you don't lose patience while reading this excellent document. Here we have. Yeah, here the last one that we ended up with in the last video was that we should not use var. We should say whether it's a constant or whether it's something that can actually change the value later on. So use const or let. There's one more thing that I want to. There was one thing that we talked about. This was where we actually went to this run right here, where we actually turn. You can actually turn types into booleans by asking. When we ask like this, then we actually ask, is there anything inside this in this variable? If it's a string, then this will actually this will be true if the string is empty. And actually I found a good article about it from a guy called brianflove.com. Then there was a good article right here. So this is the situation where it actually will return true. So if it's a string and it's empty, if it's a number and it's a 0, if it's null, if it's undefined or not a number, then you can use it. Then the double exclamation marks can be used, and then used in the if while sentence. But it's much better instead of using for what it's not. Then you can actually just ask directly. We can turn it around and then ask directly on the type instead, and then get the opposite answer, of course. But it's a better way to. It's a better way to use it, because it's easy to read when you can say, okay, this is not a number or 0 or a blank string or whatever. So that is the best case. Let us go down to exceptions right here. So when we throw a new exception, we should use the new keyword, and there's actually no technical reason for it, because it actually works in both situations. It's just like, it's more like when we create other objects, then it looks the same when we also create a new error. Both of them will actually create a new error object, so it looks nicer. Iterating over objects, yeah. So if we have an object, then in TypeScript we can actually go and look for one of the properties inside that object, and we can do that with the const x in some object. If we want to do that, we should definitely add some checks. So this is bad practice because there are no checks right here. If we want to iterate through a property in some kind of object, that means that we expect there to be an x in this object right here. Then what we should do is that we should at least make a check and ask if this object does not have that property that we are trying to get in the for loop. Then we should continue. That is the minimum. Or else we can use something like this. If for objects.keys in something, this means that now we're actually iterating through. Then we're actually iterating through a list. We get all of the keys right here. Const x off, and then we get this object.keys right here, and then some objects. So here we're actually getting a list of the keys. And if it's not there, then we would not end up right here. Another thing right here, then that this is a const, and then we can get the key and the value. So here we both get the key and the value out, and we do it with object.entries right here. So that means that we are setting key equal to the key, and that means the variable, the property name that would be x in this situation right here, and the value that are there. So that means in this situation we would actually go through all of the objects properties, and then we would actually loop through those in this loop right here. So those are the best practice ones to do, because this is not safe right here. It could end up with an error. So then we have iterating containers. Let me just check right here. We have for const x in some array, and it will counterintuitive give the arrays indices as strings, not the values. Okay, so it will actually give us the indices as a string instead. So what should we do instead then? We can use x off instead. So if you use const x off instead of in, we have in up here, then you would get the right result. Then you would actually get the value instead of the indices. And with for, you can also use for let I equal to 0 and then I less. And if you're a Java developer, you might find this more comfortable for you. Of course, in the new Java versions, you can also use the colon or the in. So this is best practice. Use a for loop and then go through each of the arrays and then actually get the value right here. So this is a common mistake when people use in, then they get the dice, and this is wrong, and they get the wrong result. Here we have consts I and x. That means that now we're actually going through some array entries. That means that we will both get the index, and we will also get the value actually. So alternative version of the above. Again, we use the keyword off just use the keyword off, and you will be good. Then you're good to go. So then we have do not use array prototype for each, set prototype for each, map prototype for each. They make code harder to debug and defeat some useful compiler checks. Okay, so we should not do something like this. Some array for each, and then we go through each of them. And then we call each function on these right here. Why should we not do that? Then consider it, and the main point right here, because the code actually works. It makes it harder to debug. It makes it harder to debug, and the compiler cannot always do the checks that it wants to. So let us try to look at some code right here. My array again and again we can see as soon as there's a red box, then you should not do that. Just so you just so we are not in any doubt that this is again a no-go. So we have for each, and then we have the function. This is the lambda where we go through each element, and then we do something right here. Char at 0. Why would we do that? Okay, we would do that for some reason right there. And you can recognize that this code is fine. X is null and it doesn't change before it is accessed, but the compiler cannot know that this for each call does not hang due to closure that was passed in and called at some later point, maybe after X was set to null. So it flags that this code as an error. The equivalent for off loop is fine. So for each, and this is a return type right here. Yeah, so we should not do that. So use the spread operator. So what should we do here with the spread operator? With the spread operator is quite good. Using the spread operator is a convenient shorthand of copying arrays and objects. When using the spread operator on an object, later values replace earlier values with the same key. So that's quite cool. I use that a lot actually. So here we have an object which only has one property, which is number right here. Then we have another object right here, and it actually uses we use a spread operator, and then we steal what was actually there, and then we override it with 5. Then we do the opposite right here. That means that actually the object in the last case right here, because first we set the number to 5, and then we use a spread operator, and then we steal all of the member variables, all of the properties from the foo here. We steal that right here by using the spread operator. We actually copy them, so we are not we're not influencing the first one right here. But it means that the num 5 would be all written with 1, and that's also what we see right here. The spread operator is used a lot, so if you don't know about it, then read up on it and try to use it a couple of times, and then you will find it really, really useful. Do not do all of this. Let us just check right here. When using the spread operator, the value spread must match what is being created. When creating an object, only objects may be used with the spread operator. When creating an array, only spread iterable primitives including null and undefined may never be spread. Okay, so let us see what we should not do. First of all, we have an object right here which has a property num equals to 7, and another property, another object right here called bar that has 5, and then it spreads something in here. It says should use foo and foo, and those might actually be undefined. So what else happens right here? Then we have the foo strings right here, creates A, B, C right here, and IDs, and then we say take this object and then spread it inside this object right here. This is an array, so we should not try to spread an array. We should only spread objects. So what should we do instead? We should say const foo should use foo. So this is a boolean. This is because first we ask if we should use it, and then we spread it afterwards. And here we do the same right here. Should we use foo, then number is 7, or else it is nothing right here. Then we have the bar right here, which says num5, and then spread foo inside it. So that means that if the foo is empty, then we will actually not get the num5 overridden. Of course, if num is 7, then it will be overridden with 7. Foo strings, again, here we have the array. Then we have some IDs right here. And again, we can, if we have an array, of course, we can spread one array into another array. That's okay. But if we have, if we want to spread amongst objects, then of course you should do that instead. The problem up here that we were trying to do right here was that we were trying to create an object, and then we tried to spread an array inside that, and that is not good. Control flow statements and blocks. So, okay, so how should we create our control flow statements? Spanning multiple lines, always use blocks for the containing code. Yeah. This is a fun one, and this is the one where there's a lot of religion involved in it, I would say, because a lot of people like to ask to do this if then something, and then just one line, then you don't need the curly brackets. Here we have the curly brackets right here. Curly bracket, curly bracket. And then what we should do, according to Google's TypeScript style guide, then we should actually create the brackets even though that there's only one line, because it looks better, and we will not create those errors where you actually press enter here and then you write some more code and you think it will only be run if clause right here is fulfilled, but it will not be run, or it will always be run because it's not inside the curly brackets right here. So don't be lazy. Create the curly brackets even though they are not needed. That's what Google tells us right here. The exception is that if statement is fitting on one line, it may elide the block. Okay, so actually, so they say it's okay if we put it all on one line. So if we take this part right here and put on one line, then it's okay what we're doing. Then we don't need the curly brackets. Okay. There are a lot of rules right here. Switch statements. All switch statements must contain a default statement group, even if it contains no code. Yeah, that makes sense. So we should always have a default, even though there's nothing to do. That is the right way to do it. Look what happens down here. Here we don't have the default situation. And it may, but non-empty statement groups case may not fall true. Empty statement groups are allowed to fall true. So we need always to add the default right here, so we know what actually happens, and also to avoid errors. So always add the default statement, even though that nothing happens in that part right there. Equality checks. Always use triple equals. Yeah, that's also an easy one to jump into when you come from another programming language and go to JavaScript and TypeScript. That is that we always need to use triple equals, because the double equality operators cause error-prone type coercions that are hard to understand and slower to implement for JavaScript virtual machines. And there's actually a nice table right here. Let us just look at that, because this is the weird part with JavaScript. When using two equal signs for JavaScript equality, some funky conversions take place. So let me just zoom in a bit. So here we have a table. So if we say 1 equal true, then it is actually here it is okay. Here's true, but then we say if we say 1 equals to the string true, okay. Here we have the string 1 equal to the number 1. That would actually end up with true. This is, if you're a Java developer, this is one of the reasons why you don't like JavaScript, I must say so. And if you ask if 1 equals to an array with with one element where the element is 1, that would also end up true. And there's a lot of weird situations right here. You can also ask for null. Null actually is the same as undefined. It's also the same as null. So, and then we have some empty arrays. An empty array equals to false actually. So if you ask empty array equal only 2 equals to false, then you will actually get a true. That is weird. There's a lot of weird right there. But you don't have to know. You don't have to look at this comparison table and know about it, because what you just do to never to think about that again, you just use triple equal sign, and you use, if it's not, then you use a exclamation mark, and then you use double equals like this. That one is easy to solve, so there would never be an issue again. Let us take one more, and then I think we will stop this video, and then I will make a part 3. Let us take the function declarations, and then we will stop after that. So first we have here we have the use function foo right here, and this is the declaration of the named functions. So this is how we declare a function. We have a name, and then it has some content right here. This is normal also for Java developers. Here we have the given above declaration that this would not compile. So here we have foo equals to, and then a short, this is the lambda. And this is because the left side right here is not okay. We need a const or a let in front of that, and then we can actually say that this should be a lambda. So lambdas are actually treated as, those are actually treated like functions. So this is just the arrow. It's called the arrow function actually. It's not just a lambda. It's an arrow function. Lambdas in Java is actually an implementation of an interface with only one method. So it is an arrow function. So all the time, so that if I've said lambdas before, then just here arrow functions. Arrow functions is the right term for it. So here we have the right one right here. So here we said const foo. Oh, now this is also wrong, because here we have we should do like this, or we should set const in front and then have the arrow functions right there. Yeah. So this is so declarations like this are unnecessary. Yes, definitely. Yeah. We will just write function foo, and this can be a bit confusing. This part is actually, if you come from Java, then then this part is a little bit confusing in the beginning. Then we have an interface. This is very, very interesting, because the interface declaration is easy when we have an object. Then we just mention all of our types, and then all of the variables that should be inside this interface right here, and then the type. If it's a function, then it's quite easy to make that function also. We just need to know that there's only one line, and the round brackets, these are the arguments that this function should take. So that means this function right here, the search function, takes a source. It also takes a substring, and then it returns a Boolean. So whether you're creating an interface for a function or for an object, they almost look the same except for the first line. If it's an object, then of course you most likely have you can have more than one line, because you can have multiple properties right there. So this is needed, especially if you want to create if you are creating a React app or a Vue app with Typescript. Or Angular, then definitely you need to know about how to create these functions right here. Then we have function expressions. This is the function expression. We have the bar function that actually takes always use arrow functions instead of the function expression defined in the function keyword. Okay, so here we have a function that takes a function, right? So it takes a function like that. Yeah, okay, but that's also fine. expression bodies versus block bodies. Let us stop here. I'm trying not to make these videos too long. So thank you very much for watching. Have a great evening, and I will make part 3 very soon. Bye-bye.